Welcome to my class, and in this I'm going to do properties of indifference curve. So we've done indifference curve, and maybe I'll just revise with you guys. What is indifference curve after all? It is the locus of a bundle of two commodities X and Y that gives the consumer the same amount of utility or satisfaction. That's what indifference curve is all about. But I want you to just go through this while uh, while I can just tell you that, see, it's in this, of course, we'll be doing properties of indifference curve. So the indifference curve technique, it was an alternative approach to the explanation of the nature of the demand schedule through marginal utility that was originally suggested by Pareto in 1909 and by the Russian economist Shitsky in 1915. But it has been popularized in the last 2 or 3 decades by J.R. Hicks in 1934. J.R. Hicks and R.G.D. Allen, they wrote an article entitled A Reconsideration of the Theory of Value in Economics, presenting the indifference curve technique. So, it was written by J.R. Hicks that he gave a detailed presentation of the indifference curve technique in Value and Capital. Now, the great importance or the merit of indifference curve analysis, it is claimed, is that it is our inability to measure utility, and it removes our dependence on the necessarily hypothetical character of the utility analysis. So it was Marshallian's cardinal approach. Now, besides, it makes it possible to distinguish clearly the income and substitution effects of a change in the price of a purchased good. An indifference curve is based on the assumption that every consumer has a scale of preference between two or more goods, and each scale of preference consists of a number of alternative combinations of two goods which give the consumer a certain amount of satisfaction. It is important to note that here that all the different alternative combinations of the two goods give the same satisfaction, so that if he chooses any one of the many alternative combinations, he is indifferent about other combinations. So we did talk about oranges and apple, and we saw the various combinations A, B, C and D, and we saw that it gave the same amount of satisfaction. So he's indifferent to the different combinations there. So we did see the combinations of apple and oranges. The curve obtained by plotting the various combinations is known as indifference curve. So if you see in the previous classes, I've talked about the table, the schedule, and also drawn the indifference curve based on that. So just go through that. So this curve shows nothing about the absolute amount of satisfaction, however, obtained, but it merely tells you about the various combinations which will yield equal satisfaction. So an indifference curve is precisely what we can call it is the iso-utility curve. So what is it? It's an iso-utility curve which shows that every point on a given indifference curve gives the same amount of satisfaction to the consumer, even though each point represents a different combination of the two goods. So it is a iso-utility curve, as I've put it. So as we see that the different combinations give him the same amount of satisfaction. Okay, in the first 2-3 lines that I've written over there. So now, armed with this knowledge, we are going to do the properties of indifference curve. So we know what is an indifference curve. Once again, we sort of revised it, and now we're going to do what are the properties. So one property is that it slopes downwards. So if it takes into account that when we have two goods, if we are going to increase one of it, we have got to give up the other. So that is it. So I see slope downwards from left to right. It means that the indifference curve has a negative slope. So it implies that if a consumer decides to have more of one good, he must have less of the other. Simply as that. It is only then that the satisfaction level would remain constant at different points of the indifference curve. Okay. So given all these points here, if you see the points, all the points that any point on this, any given point on this, A, B, C or D, A, B, C or D, all will give him the same amount of satisfaction. So that is important. Okay. So that is why it slopes downwards from left to right. And also we can say, even in this we can mention that is because of marginal rate of substitution, which when we'll talk about the other characteristics, we can do that, convex to the origin. Okay, now, so the next is, this was one. So the next one that we can talk about is that the higher the indifference curve, right of it, it shows more utility. Any indifference curve which is higher than the one, it shows more satisfaction, higher level of satisfaction. So if you see a set of indifference curve, like for example, if you see these two, say IC2 will give you more satisfaction, simply because the indifference curve which is, okay, the indifference curve which is placed higher gives you higher utility. So indifference curve 2 has higher utility than the first one, the right, any indifference curve to the right side. So if you're talking about this is based on the assumption more goods, more utility implies that the utility is an increasing function of consumption. When a function is always increasing, it is called monotonic function. So a person's preference for more in a bundle is known as monotonic preference. So if a bundle has more of X commodity and not less than of Y, then obviously being a rational consumer, he will choose the one with that. Now for example, if you see that, like if there are two curves, IC1 and IC2, and if he takes at IC1, he has the same amount of good X and so much amount of good X, but good Y he has and so much of good X. But if we go to IC2, what happens? Yes, good Y remains the same and good X increases. So this is what is higher IC curve represents higher utility. So talking about that, then the third characteristic is that it is strictly convex to the origin. Indifference curve is convex to the origin. Now what is this? What does this mean? So it means, so what does it say? It means that the slope of indifference curve tends to decline as we move along the indifference curve from left to right. The slope of the IC curve is called the marginal rate of substitution. Now this indicates the rate at which the consumer is willing to substitute what? Y for X. Y good for X good. One good for another. Now the question is, why do you think that the marginal rate of substitution should decline? Simply because as more and more units of X are consumed by the consumer, his intensity of desire for X good tends to go down, which implies that the marginal utility of good X tends to fall This is in accordance with the law of diminishing marginal utility. Now let's take the other one, y good. On the other hand, as more and more units of good y are given up, his intensity of desire for good y tends to rise, implying that marginal utility of good y tends to rise with every additional unit of it being sacrificed. So it is because of this, for every successive unit of x, the consumer is willing to give up less and less amount of good y. So, sacrificing y per unit of additional x tends to fall as we move down the indifference curve. So, this is what you have seen. This is the property in which you see almost like when you see the indifference curve, it sort of flattens out later on. That's because of that reason. So, another property is that two indifference curves do not or cannot intersect. So, why? Because see, we've already talked that indifference curve shows isoutility. Like it tells you about the same amount of utility or satisfaction on each curve. So, how will they? Just imagine, how are they going to intersect? They cannot. So, and if they do, you will not get logical result. Now, look, consider points A and B. They are on the same IC1. Therefore, these are equal to terms of level of satisfaction, so that A is equal to B. Likewise, A is equal to C, as they are on the same IC2. So, having said that, since A is equal to B and A is equal to C, we can conclude that B is equal to C. Well, this is not logical, because at both B and C, the consumption of good Y is the same, that is okay, that is equal to okay. But at C, the consumption of good X is equal to Kc is greater than at B is equal to Kp, implying that C must be offering higher level of satisfaction than B. So, that is there, as you see these points. And then the last one is that the IC curve does not touch either x or y axis. This is simply because indifference curve analysis considers the consumption of two goods simultaneously. That is the assumption. So, if IC touches y axis, it would mean that the consumption of good x is 0. Likewise, if IC touches x-axis, it would mean that the consumption of y is 0. So, well, these are the properties of indifference curve that you should go through. You can get a question as, either you can get a question for all the properties, or sometimes they'll ask you one or the other question. Like, for example, why is it convex to the origin? Why can't indifference curve cross each other? So go through that. Go through the lesson.